Have you ever walked into a room and the air just feels heavy or stale? Well, today we're going to pull back the curtain on the invisible science that makes our spaces feel fresh and alive. We're diving into how buildings actually breathe. You know the feeling, right? You walk into a room and it's just stuffy. The air feels stagnant, maybe a bit too warm. It's not your imagination. It's a sign that the building you're in isn't really breathing the way it should be. So what's actually going on here? Well, it helps to think of buildings almost like they're living things. Seriously, to stay healthy and comfortable for us, they need to exhale the old, stale air and inhale fresh air from outside. This whole process, this constant exchange, is what we call ventilation. Now, the oldest and, simplest way to do this is with natural ventilation. It's all about designing a building to work with nature, not against it. It's about harnessing the forces that are already out there, like the wind and even temperature, to do all the hard work for us. So how do we actually put these natural forces to work? It really boils down to three key principles that architects have been using for centuries to make buildings breathe all on their own. Let's break them down. First up is something called wind action, but you probably know it as cross-ventilation. This is just pure, simple physics. When wind hits one side of a building, it creates a high-pressure area, and that air naturally wants to rush to the other side where there's lower pressure. Boom, you've got a breeze flowing right through your space. And here's the cool part, the practical tip. To make this happen, all you really need is an entrance and an exit for the air. If you just put windows on opposite walls or even on walls next to each other, you give that wind a super clear path to travel. Okay, principle number 2 is the stack effect. This one is all about temperature. We all learned this in school, right? Hot air rises. Well, the stack effect uses that simple fact. The warm, stale air inside your home gets lighter, rises up, and escapes through high openings, think skylights or high windows. And that movement literally pulls cooler, fresher air in through openings lower down. Honestly, the best way to picture this is to think of your house as one giant chimney. It creates this constant, natural, upward draft that just keeps cycling the air, all without any fans or machines. Pretty clever. And finally, we've got the Venturi effect. Now, this one might seem a little backwards at first, but if you force air through a narrow opening, like a window that's just cracked open, and it enters a bigger room, the air actually speeds up. Architects can use this little trick to create a faster, more targeted breeze right where it's needed most. Okay, so natural ventilation is amazing. But what happens when there's no wind? Or what if the temperature outside is exactly the same as it is inside? And what about those huge, deep office buildings or spaces with no windows at all? Well, that's when nature needs a little help. And that help has a name, mechanical ventilation. The difference is really simple. Instead of relying on natural forces like wind and heat, mechanical systems use fans, ducts, and machines to physically push and pull the air exactly where we want it to go. Now, when we start talking about mechanical systems, there's one number that matters more than anything else: air changes per hour, or just ACH. This is the gold standard. It tells you exactly how many times the entire volume of air in a room gets completely swapped out for fresh air in a single hour. And get this, the ACH you need can be wildly different depending on the room. Just look at this. A busy commercial kitchen with all that smoke and steam might need a whopping 18 air changes every hour to stay safe and clear. But a typical office, it might only need about 5. This is why you need machines, to guarantee you're getting the right amount of fresh air. All right, let's talk about the king of mechanical air control, the air conditioner. To most of us, it's just a magic box that makes things cold. But it's actually a really fascinating continuous loop. So let's peek inside that box for a second. It all comes down to something called the refrigeration cycle. Stick with me here. Step 1. Inside your house, a super cold liquid refrigerant flows through coils and absorbs heat from your warm room, which turns it into a gas. Step 2. That gas gets pumped to a compressor, which, you guessed it, compresses it, making it super, super hot. Step 3. This hot gas goes to the unit outside, the condenser, and a fan blows air over it, releasing all that heat it picked up from your room into the outdoors. And finally, step 4, the refrigerant, now a liquid again, goes through an expansion valve that makes it ice cold, and it's ready to go back inside and grab more heat. It's just a machine that moves heat from inside to outside. Okay, you've soaked up all the science. Now let's see what's stuck. It's time for a little pop quiz to test your ventilation IQ. You ready? All right, first question. The stack effect. When does it work best? Think about what gets that air moving upwards. And the answer is B. You got it. The bigger that temperature difference is, say it's really warm inside and cold outside, the stronger that chimney effect becomes and the faster the air cycles. Question number 2. You want to get a nice breeze going with some cross ventilation. Where are you going to put those windows? Yup, B again, on opposite walls. You got to give the wind that clear, straight shot right through the building. Question 3. This one's about your AC. Which one of these parts is the one that's actually dumping the heat from your house outside? That's the one. It's C, the condenser. That's the big unit outside with the fan. It's literally condensing that hot gas back into a liquid by getting rid of all that heat. And for our last question, what is that super important metric ACH actually measuring? And the final answer is B. ACH tells us how many times the entire volume of air in a space is completely swapped out with fresh air every single hour. An absolutely crucial number for healthy buildings. So the next time you feel that cool breeze from an open window or that blast of relief from an air conditioner, you'll know about the invisible forces making it all happen. And that leaves us with just one last question for you to think about. The building you're in right now is breathing. Is it breathing well?